Okay, so this is another free response question from the 2016 exam, which I think gives us some good practice on what we would be likely to see in some way, shape, or form on the actual exam. You only have two open-ended questions. The statistical inference will definitely be part of that, but maybe to save time in some way, shape, or form, they might do something like they're doing in Part B, or Part A, where it says assume the conditions for inference have been met, so it saves you some time. So this particular question is focusing on confidence intervals, conditions for inference, and then also that question of what interval to use and when. So they conduct a poll of 1,048 adults in the U.S. They give them two statements. You have the environment statement that says protection of the environment should be given priority over economic growth, and then the economy statement says economic growth should be given priority over protection of the environment. So in the results that they got back, 58% agreed with the first statement that favored the environment, 37% agreed with the economy statement, and then there were 5% that had no preference. Okay? So what they want us to do is construct and interpret a 95% confidence interval for the proportion of adults who would have chosen the economy statement. Okay? So the first thing I want to ask you is what's our point estimate, or p hat, for that parameter. Okay, so hopefully you looked above there and you can see our point estimate, or our p hat, should be 37% or 0.37. Okay, so we want to identify the parameter of interest. Okay, our parameter of interest, we would use the symbol p, and p is the true proportion, and they give it to us right here in the statement: 95% confidence interval for the proportion of all adults who would have chosen economy statement. So you just write P equals true proportion of all adults. Just copy it right off the paper. It's right there. Okay. So the next question I'm going to give you is a calculator question. How would we run this on our calculator if we want a 95% confidence interval for proportion of all adults? What option are you looking for on your calculator to enter this? So hopefully you chose the 1 proportion z interval. Okay. So now when we run that on the calculator, we're going to go to stat, test, and I want the 1 proportion z interval. It's not on my screen right away. I have to go find it. It's all the way down there at letter A. I'm just going to go up to it. So I have my 1 proportion z interval. So what happens here, they didn't give me an actual number out of the 1,048. They said 37%. So that's going to be 0.37 times the sample size, and that was 1,048. Now, if we leave that as such, we're going to have a problem. The calculator is not going to run this confidence interval for us. It's going to give us an error. So just put my sample size in. They could not have possibly had 387.76 people agree with that. The calculator knows that. So you need to tell the calculator it was 388. Okay, and I believe we wanted a 95% confidence interval. Calculate. Okay, so I get an interval from 0.341 to 0.399. That will be my published interval. Calculate that. But remember the work that we want to be able to show to the AP readers in a situation like this. Number one, we want to say something like P equals that parameter of interest, right? So you want to make sure that you state the parameter of interest, P, and you're going to call it the true proportion of all U.S. adults who would select the economy statement. for our interval, remember, you don't have to show all the work, but you could at least just write down p hat for the confidence interval, plus or minus z star times p hat times 1 minus p hat all over n. You can let the calculator do the heavy lifting for you from there. I recommend you just put the symbols in. If we put numbers, what did that look like? It would be 0.37 plus or minus 1.96. Those are the numbers, but the calculator is going to do all the work for us. What makes me nervous about entering those numbers is that you could make an error somewhere in there, whereas the calculator, if you run the correct test, you should be in good shape when it comes to that. Okay, and then finally, you want to construct and interpret. So make sure that you make the statement that we are 95% confident that P is contained in this interval. Okay, that's all. We don't have to be fancy and talk about the meaning of confidence. You just say you're 95% confident that P is contained in that interval. Not that 0.37 or P hat is in that interval, but P, the parameter of interest. Right? Remember, notice the difference here. This is what I'm estimating. This number I have, I used it to estimate it. Okay, one we make an inference about, one we actually have. Okay, so part B says one of the conditions for inference that was met in that the number who chose the economy statement and the number who did not were both greater than 10, right? This was like 376 or something, right? We got 0.37 times 1048, and then also 0.58 times 1048. Or sorry, 0.63 times 1048. There's another 5% there that shows nothing. Why is that condition necessary? Okay, I want you to answer that question in your Edpuzzle question. Come up next. Why would that condition be necessary? What's our reason for that? Okay, so hopefully your rationale there included something about the sampling distribution of p hats, or sampling distribution of sample proportions. We have to be able to believe that this 0.37 number comes from a distribution of p hats that are all centered around p, the parameter of interest. We have to be believing this. We don't know what p is, but we know that we get all these p hats that live around it, and they are normally distributed. Okay, that's the only reason the 1.96 number is valid for 95%. Okay, all of these p hats live in a normal distribution around p, so therefore we know even if 0.37 is over here or if 0.37 is over here, we build an interval around it, and then we can be 95% confident that p is contained in that interval. So your answer to B, you would want to say that it's the it's assuming that we have a normal shape sampling distribution of sample proportions. Okay. Part C, a suggestion was made to use a two-sample Z interval for a difference between proportions to investigate whether the difference in proportions between adults in the United States who would have chosen the environment statement and adults who have chosen the economy statement is statistically significant. Is the two-sample Z interval for a difference between proportions an appropriate procedure? Justify your answer. So you see that you have two different sample proportions here, right? You have 58% out of the 1,048, 37% out of the 1,048. What we're asking is it reasonable to subtract those two and make a confidence interval for difference between two proportions? Let's answer that, and then we'll finish up. So the correct answer there would be no, it's not reasonable, and the easiest way to answer it is that you don't have two samples. You only have one sample. You have two sample proportions. 0.58 is a different proportion from 0.37, but they came from the same. They came from that same 1,048. If I go to the calculator to do a two-proportion Z test, or Z interval, or test, I'll just go to the two-proportion Z test. It's the same setup as the Z interval. It'll be a ways down there, but the two-proportion, well, let's do the interval. Don't confuse anyone. Okay, when I go to do my two-proportion Z interval, what happens? It asks me for two different samples, N1 and N2. Well, I don't have two different samples. I only have one, 1,048. So to do the two proportion Z interval, maybe we take a sample of 1,048 married adults and 1,048 single adults, right? Or 1,048 adults under 30 and 1,048 adults over 30, something like that. Then you have two different samples. But here you just have this one sample of 1,048. They're not independent of each other, so the two proportion Z interval is not appropriate there.